Okay. So let's check. So this is the code we had written in the past. You can also test this again. So first start a game controller. So middle foundation, Berlin, this is Behuman. So this could work. Okay.
And it still works.
So it still kind of sort of works. Let's see. Yeah, so the game state changes. We change the game state. Yep. Okay. Yeah, we can undo this, and then we have game state 0 again. So, kind of get some data from the game controller. So, I'm doing this in WSL, so the Windows subsystem for Linux in Windows 11. And one thing we should note here is that this is some sort of internal IP address. Yeah, so this could be a problem later if we actually want to send data to the game controller. But one thing after another. So so the rules sort of state we get. Actually, let's look it up because I don't know exactly again. So what's the rule? Like I want to look up how often the game controller message is sent. So
2 times per second.
Yeah, so we have the game controller sends a control message at 2 Hertz, meaning 2 times a second. Yeah, and via broadcast. So, and the game controller receives status message from the robot players, which must send at the rate between 0.5 Hertz and 2 Hertz. So, what we can do and what we did with our original C++ implementation is whenever we receive a control message from the game controller, we send basically a reply back with our status message. So we can implement this. So then we are at the maximum rate if we get every control message. We will never be we will never send too much data. We just could get away with sending less data. So.
Does it matter if we send one message less per second?
No. It's like if there is a game state visualizer, so the things that's shown on the big screens on every field, like if they are set up, the data is only used for this. And for the game controller to know which robot is active. So. But yeah, we can just implement this. So, so here this is a demo header file showing us what kind of data the RoboCup game controller return data expects. So we kind of have to implement this in Rust. So we can just do this here. Do implement reply. Okay. So
we have structs in Rust as well, right?
Yes, and we get to this later in the demo here. So okay. So here we have a socket thing, and so this is something, and it has a receive from method. Well, it also has a send to thing, right? So here it expects a reference to some data, and we get to this and the target address. So what could the target address be?
The source address we got in line 14.
So we could do something like this, right? So yeah.
Yes.
And this source address, what would it be? Well, we need to it would probably be the IP address with support, right? So we print it here, and we get the IP address and support.
Yeah.
So this is support from the game controller, right? So we don't want to send to this port. Okay. So target address, like since we don't really specify a type here, which not really cool, but this thing, whatever it is, has a function set port. I looked it up.
Okay.
And yeah, well, we need to set the game controller return port. So this is a const. So let me look it up. So yeah. So this port, you can it says it's somewhere here, yeah, in the README of the game controller repository. So the status message should be sent not as a broadcast message, but as a message to the IP address of the game controller support. So so few things, or one thing to note here is the game controller could be hijacked. So if there is a second game controller running in the same network, this implementation will always just react to the latest message. So whatever it gets.
Someone could add a second game controller and our robots would get disqualified because they don't reply to the original game.
No, like whenever we get a message from the original, we would still reply. But we would do random shit because the state, like later our behavior would react to the data the game controller sends.
Oh.
So, and if, for example, one thing that's penalized, the other that doesn't say it. Right. So it would be penalized, unpenalized, penalized, unpenalized. So there's no real security here, right? So this is just one thing to note. I have to close my window. There's some soccer players making some noise. Okay. So, like, just from a security standpoint, this is not really secure, but also this is not really the point here. Like technically we could build something saying like, oh, if the source address in one iteration of the loop is like not equal to the source address before, we would go in some sort of error state.
Yeah.
Right, but that also would trigger if you leave the robot on between games.
Yeah. So we have to implement.
So any kind of defense mechanism we could add here would also be problematic from just a procedure kind of workflow at Robocup. So it's best to make sure only one game controller is running. This is also really easy to detect. There should only ever be one computer sending something to this port, or sending broadcast messages to 3838, right? So tools like Wireshark would make it trivially easy to just scan the network. Right? And technically, whoever started second game controller is in violation of the rules. Yeah. So, but yeah. So this is just one thing to note. Like, this is the behavior that we are actually building, which is by default not really secure. So, something that I know is that this, because I looked it up before, this return data needs to be an array of bytes. Okay. So, we do that. Okay. From what we learned before, this is an array containing 32 elements of type unsigned integer with 8 bits, meaning a byte.
So, yes.
Okay. So, why 32 elements? Well, I counted before. Okay. So, let's look at, oh no, we have it open here. So we need to send a header. This is this string, okay? But we shouldn't send a string. We should send bytes, not a string. String is not a byte or an array of bytes. I mean, technically a string is an array of bytes, but we already need to send an array of bytes and not an array of bytes. So we cannot put a string here.
Okay.
Okay.
And
so if you would do something like this, don't know if this is even valid Rust right now. This is a string.
Yes.
So you could interpret this like in a lot of languages. You can get the 0th element of this string, and you would get the R, right? So it sort of behaves like an array. So what we need here, so we get the byte representation of R. So this is also very similar to what you can do in Python.
Yes.
Okay, so now we have our first 4 elements. So then it says a version. So has to be set to a version. The game controller return struct version is 4. So we send 4. So standard integers, if we do it like this, are unsigned. Or this would be automatically cast to this. So we don't need to do anything extra.
Okay.
So here we can now do a player number. So I just put 1. So
yep.
So here I find like in the structure it says player number. Then the team number, well, let's use our team number. Berlin United is team number 4. So, and fallen, yeah, well, we are not fallen. Okay. So now we need to send an array of floating point values, and the array has size 3. Okay.
So one float is 4 bytes.
So how we do this? First we create values, right? So yeah. So let's unpack this a little bit. So first we could like let's just look at this, right? So we say the one value, pose x, right? So we don't care about it. This could be an array here, right? So we have x, y, and direction. Okay, and what should look like sort of familiar 0.0 is a value, right?
Yes.
We specify that this should be a 32-bit floating point value. It could be 64 bits, but in C or C++, float is 32. Usually. Okay. Actually, it depends on the compiler. and or your version of libc for this specific thing. So it's actually not guaranteed what it is. So, but in all the systems we are working with, it's 32 bits. So,
Okay.
and now we don't want a 32-bit floating point value. We want it
Why?
as bytes.
Yeah.
So I make it, yeah? So have you ever seen, or have you any idea of what the LE could mean here?
It means little endian.
Okay, do you know what little endian means?
I don't know the definition anymore. No.
So,
There's something to do in which direction the
yeah.
binary is interpreted.
Yeah, so can I just draw? So if you have like some bytes, right? So I don't know, just some random bits actually, right? So now you want to say them out loud to someone. From which direction do you start? What is the first value? Is this the 0 here, the first value, or this one, the first value? So,
I
and
would start
little
with
endian means
0.
you use the lowest value here. So, by convention, the rightmost value is the lowest value. We say this first. Yeah. So if someone tells you the bits one after another, you would write from right to left. So this is what little endian means, nothing more.
Okay.
And it's only ever like usually it's only ever relevant for data transmission. So okay. So now we have it as little endian bytes. Okay.
Yes.
So 8 bits together as so. Okay. Now we have the bytes, right? That meaning that pos x is actually an array of bytes because it's more than one, right?
Yeah.
So since it's 32 bits, meaning we have 4 bytes. So 4 times 8 is 32. So all we
Yep.
do is we get the first one, second one, third one, and fourth one. Okay?
Yes.
So this is how you transmit the bytes. So, and we do this for pos y, exactly the same thing, right? There's nothing special about this. Okay. Can you like understand this? Like, do you have like
Yeah.
a mental picture of what we're doing?
Yeah, we need to unpack the array of bytes because you can't put an array in an array.
Yeah. So, and I'm doing this for all the other required values, right?
Yep.
So, and yeah, and basically this is it already. Okay. So ball age, just one value, right? So, and
Yep.
then the ball position, right, has x, y. So, yeah. All right. Then, what I would expect if I now run this code and I didn't make a mistake is that here this x would turn green, meaning the robot control got data back from the robot. Why Plu1? Because we set the team number to Berlin United and player number to 1.
Yep.
Okay. And I forgot somewhere this. Yeah. See? It's green.
It
Check mark.
works.
So, this is actually the minimal implementation of what we need for RoboCup.
Okay.
Something that says, hey, game controller, I'm here. Okay.
Yes.
So, yeah. And I think it's not too complicated, right? Like if you know what you actually need to do, then I think like the code is still really ugly. Like we wouldn't actually program like this.
Of course, but it works.
Yeah. So yeah. So you can kind of remove this line. Okay, so now clean up a little bit the code. So later on, like here we don't like we have some sort of data array, right? And if we know which bytes to get, we can interpret this in a little kind of, right?
Yeah.
Yeah. So it's not really usable, and also we need to make like in the end other parts of the code should like get easy access to the data that the game controller sends.
Yeah.
Things like behavior would need to know, like, am I penalized or not, or like other kind of states. So we should kind of implement this a little bit better. So how can we do this? You said it yourself.
We represent the data as structs,
Yeah.
which
Yeah.
Rust has, so we can use this.
Yeah. So here we have structs, and we kind of like like it looks kind of easy, right? We have the struct, 3 values, all unsigned int.
So we can say robotinfo.penalty and we get the penalty value anywhere we want if we have.
Yeah.
Right?
Yeah. I mean, would need to write data into the robot info, and then other people could use it, right? So this is kind of like how you could do a struct. So the pub is only important later after we refactor everything. So that's actually modular. So this is needed for some kind of module architecture later on. So you could like get rid of the pub here. And have we talked about what this means?
No.
Okay. So like have you like ever worked with inheritance in Python or any other language?
Yes, I have.
So like when you like sort of inherit or like are subclass of something, right?
Yes.
Then you can use methods of the parent. Okay?
Yeah.
So this is a core principle in object-oriented programming. So Rust does it a little bit different. So like it has a trait system, which is somewhat related to the class kind of stuff, but they look at it from a different angle, I would say. You build traits, and then different sort of classes in quotes can use this if the trait is like written in generic enough. So so here what's actually happening is we can print an element of robot info, and the print macro would know what to do with it, because it knows how to display each of the elements. So there's also I think it's written like this default trait. So we could create then an like something at a equals I think you would write it like this. I don't know if you need to do it like this. Let's test. No. Okay. Can I do it like this? Yeah, maybe not. But it. Yeah, I have to look up the syntax exactly. But actually, this default trait should sort of make sure we can create something without specifying other members. Yeah. Let me look it up.
Like two double points and then default might be the correct syntax.
Like just yeah. Let me just look it up. Can I do this? Okay. Yeah. You were right. We need to actually call this so it doesn't happen automatically. Yeah. So, but if this would not work if we didn't say that the trait is implemented, right? So that means this function wouldn't come, right?
Yeah.
So
traits are functions we can use without structs if we derive from them.
Yeah. So, like when you like in C++ or Python, like when you like want to do something like this, you have strict inheritance. So, and so this means in the essence that the classes need to be also kind of the same, right?
Yes.
But here doesn't mean that at all. So the structs could be completely different, like they have nothing to do with each other, and can still use the same traits. So you don't really inherit this, right?
Okay.
But it's kind of like from a user perspective, it might be kind of like inheritance, without the drawbacks that you actually like inherit something. Basically, it says, this behavior I also want for my struct.
Okay.
Yeah.
And what does default do?
It just gives default values for all this for all these members here. So 0 by default.
Okay.
Yeah. Okay, now we kind of need to do this is basically just copy paste. Okay. So we have robot info, team info. This is just here we use Rust has a built-in type vec. Yeah, it's just similar to the vector type in C++ or a list in Python.
Okay.
Yep. Okay. Yeah. So this is basically we just define some structs. Nothing uses it, right? So
we still need to write into the structs.
Yep. And this is now a little bit more complicated. So Like let's look at from this perspective first. So actually here we want to, like, what do we want to do actually is we want to pass the incoming data and put, like, the data we get or the data that's in here, we want to put into the right fields of the struct.
Yes.
This is what we actually want to do. So yeah, so and this would be GC data. Okay. Yeah, number of bytes. So, and then we don't need this anymore, right? So this slice. So pass given data received and put it in the structs. Okay. So here I'm calling a function from something that's not even implemented, like a struct, right? So
yep, we still need to implement parse.
Yeah. So I mean, this robot code game control data is a struct. So how do we like now we implement something for it? And I would just copy paste the whole code and explain this later because this is kind of complicated. Okay. So here, that's how you implement stuff for a struct. So that's, I think like it could be sort of seen as a trait. So we implement this function for this type of data. Okay. So
yep.
what should the function do? So it takes a reference to an array of bytes.
Yes.
And we call it bytes internally in this function. And it returns this data self, right?
Okay.
But there could be an error. So we wrap it in option. So this is something you like how you sort of work with return data from functions in Rust.
Okay.
Because we always need to, like, at compile time, we need to know what's the type of what it's returned. Well, if the function could throw an error, then the type is not defined. Right? So it could either be an error or what we actually want. So at compile time, we don't know what the type is. The return type of the function. So the way we get around this, well, we always return an option of it. So, and basically it can, there's also a result type, I think. Yeah, not sure about the details here exactly, but later on we can like work with it. So this sum function here will return the data if there is any. So then we can work with it. So here, another thing that's not implemented, we have a reader. Like, I don't know if you ever looked at what we did with the log crawler where we pass the log files?
Not in detail.
So, but this is sort of copied from this Python implementation. So we have a reader object and yeah, we can initialize it and give it the bytes thing. So bytes is a reference to a byte array. Okay. Then we just assume, so the reader object has the function read byte. Okay. And so here the question mark is also like, so we don't need to do explicit error handling here. We put the question mark here, basically like a macro, and we get the data, or it errors out somehow, the function. So, but yeah, we get 4 bytes and put it in array. Okay.
Yep.
Then we read another byte and we call this version. Okay. Then package
Yep.
number and so on and so on. So whatever is written here. And then we have a function read team. Okay. That
Okay.
reads the team data.
So reader tracks internally which byte we already read, and then it counts up.
Yep.
Now where we currently are in the byte array.
Yeah. And here we call it, and actually we would like do this more like this. So since this function could error out, so we don't always get data or cannot explicitly expect this, right? So we have to do it like this. So if there's some data, then we do something. Okay, how do we do it? Like, we don't want to access the things explicitly anymore. This we need to rewrite anyway, right? It always fucks up. This, yeah. But we need to change the print line anyway, but this code we'll just put in here.
Yep.
So if we got valid passed game control data, then we reply something.
Yes.
So, and if not, we are not doing anything, right? So we just go to the next loop iteration.
So now we avoid people sending packages on this port that are don't have the valid game controller header.
Yep. Yo. Okay, so now the really complicated part. There's also some things that I don't completely understand yet. You can look up together.
Okay.
So we create a struct. Okay, reader has a value slice. Okay, and this is a reference to an array of bytes. So what does the tick A mean? This is an explicitly annotated lifetime, which I don't know why we need this. We can also like check if we don't need this. So this is actually like something that I found on the internet, like how to like build this kind of reader thing, because this is like a standard parser in the end. Like any kind of parser would work like this. It really doesn't matter what you parse. So, but this is what I found. So, like ignore the lifetime stuff for now. Okay. New gets the reference to the byte array and returns a reference to itself, to the reader object.
Yeah.
This is any constructor, right?
Yeah.
So the read unsigned read byte thing. So it returns a byte or the option of it, right? So so this will return the value if it actually is 1. So so an array has a function by default split first. So you get the first element and then the rest of the array.
Oh, okay.
Right. So I mean you would like probably do this a little bit different in Python or so, but it's basically slicing, right?
Yep.
So, and then what we do is, the rest of the array is now the slice of the reader. So if you imagine you're going through an array and you have your pointer, or sometimes it's called cursor, on the first element. When you read it, you put your cursor on the second element. and so on.
And
so this is how you go through the array.
yeah, we drop the already read elements like this.
Yeah, I mean, yeah, we don't really drop any data or delete any data or something like this. We also not copying like part of the array to a new array or anything, right?
We don't have
in essence, we remember
anymore in the reader.
Yeah. So, and yeah, we do it similar like when we read 2 bytes, right? So,
yes.
So first we check, yeah, well, can we actually read 2 bytes? And then we say unsigned 16, unsigned int 16 bits, and then from little endian bytes, right? So here's the order is important, right? So
yep.
We could have used big endian, but then we need to do it on both sides, right? But yeah, but here it's the first 8 bits from the right side, and this is the second 8 bits from the right side, right? So, and we create a value out of it, right? We advance the cursor of the array by 2. This is the slicing syntax in Rust.
Okay.
So in Python, I think it would be something like this, right?
Yeah. Like omit the first 2 elements.
Yeah. And so on. And here, if it's a signed integer, then only this changes here, right? The type.
Yes.
Yeah. And read team is just use everything we used before together. Yeah. Here we create a vector. So this is like more familiar if you see in C++. It basically has the same function. We create space in like memory for 20 elements.
Okay.
And yeah, and then we like read data and put this in robot info, right? Yeah.
There could be 20 players in a team.
This is max num players, and this is, I think, 20. Yeah.
Okay.
This is just the implementation. Yeah, and we will always like error out if we can't read a byte, right? So we don't expect data from 20 players. So this is what this question mark does for us, right? So we don't actually need to handle the case manually that we can't read a byte. Then it's done, right? And then no more data. Okay. Yeah.
So it wouldn't work if we read team info. We can't read team info first because it's not first in the array, anyways. But if team info was stored at the beginning of the array, we would error out.
No, then like no parser could actually really work, because then it means like then you don't know where team info ends.
Okay.
So like where's the rest of the data? You don't know, because the number of players is variable.
Okay, so team info has to be last.
Yeah, and this has nothing to do with the programming language. So this is like how you structure data and send it over network. So how do you deal with like not know what the end of it is, right? So there are other techniques you could use, like to denote when your like verbal data ends, right? For a string, what a usual thing is, you send /null so actually 0 character, right? And this this means 0 terminated strings. So it's just a /0 at the end of a string. That means the string is ending.
Oh.
So this is just one way how to do it, like how to show the receiver of your message that you're done, right?
Yep.
And those kind of control mechanisms predates the internet. So like over radio, you say over or over and out, or like telegrams, you say a stop, something like this. So it's
Yep.
always important to somehow know when a variable length message is ending.
Yep.
Yeah.
No, we don't listen to any kind of stop signal. We just think if the data is,
Oh.
if there's no data anymore, we finished reading it.
Yeah. So.
Okay, I just never thought about why the structure is structured like this before.
Yeah. So. Yeah. So I'm still confused about the lifetime thing. So this is, I just found it and it worked. So I didn't question this too much. Right? So.
Yep.
So, like, let's put in a better print line thingy here. So, and here, so we expect to access the data if we did everything correctly. So the GC data is of type RoboCup control data.
Yep.
Because the pass function returns self. So, and then we would expect that we can access the members of the struct.
Yes.
So, if we did everything correctly, we didn't, because in my test application I named it differently. So, but here, okay, 600 seconds left on the clock. Because I undoed everything. So we can ready, set, play, and then obviously we shoot a goal against BHuman, and then you see the score changed, right?
Yeah.
So, okay, set, playing, and another goal. Okay. So at least in our fantasies we win against BHuman. Yeah. So this is how it kind of works. Okay.
Yes.
Okay. So let's do an experiment. So why do we need this shit here? Okay, let's replace this and see if it still compiles.
And it's still in 947.
Oh yeah. Yeah.
Okay, it needs the lifetime parameter.
Yeah, somehow. Yeah. Yeah. It explicitly tells me like, no, I need it. So, but I don't really understand why. Okay. So, it's definitely one of your homeworks to also like look at it, why that would, like, first of all, what it is, and then why we would need it here, right? So.
Okay.
So
I can do that.
Basically, you can say like how, like a variable, like so only one so okay, how to explain this? In general, so you have a variable, right?
Yes.
And you wanna like, okay, yeah, let blah, right? Because only one or something like this. So, okay, yeah, now I can sort of print blah, right? So I'm not bothering with the actual correct syntax here, right? So I can access this, okay?
Yes.
So, but there is something like scopes, right? So, so now, like,
you can't access it.
Yeah, so this wouldn't be valid here anymore, so it wouldn't. So this is something like to consider. So where is a variable valid, but also if you do this, let's return this, right? And now you have a function. So yeah, it's the syntax of like, just fn here, fn flup, right? And just a simple function, right? And now you want to do something here. So doesn't matter how the variable is called. So print a, right? And
yep.
So like if you do it like this, it could be like since it's not an actual implementation, so you could make it that it actually copies the value, right? For primitive data types, that kind of could work, right? So, but the question is, plup, blah, right? So, can this work? So, because you're giving the variable to this function, so how can this function do something with it? So, this variable, like you don't return the variable again. So this function borrowed the value.
And it didn't give it back.
Yeah. So I think like the Rust book has an example similar to this. So and so you like this means there's some implicit lifetime. So where's the variable valid, where it is not. So this is like a very bad explanation of how this kind of works. The Rust book definitely explains it much better. So the question is, why doesn't it work here that it's implicit? Why do we need to make it explicit here?
Okay.
This is what I don't get. So, and can just look at the Rust book. So, yeah. So this is explains the relevance thing. Yeah. So yeah, here is something already like this is actually the simplest case where you can break this, right? So create a simple string, okay, and then the R1 is a mutable reference to this string, and then do it again. So and
okay.
Yeah. So this already breaks the ownership kind of thing. So yeah. Do we find something about the lifetime thing? Can I look? Okay. Yeah. Okay. Okay. So here they explain like you can like use some generic types so that something works for different types. Okay.
Okay.
But we don't do this in our like reader at all, right? So
No.
okay.
But the size of the object we are reading is not set. Maybe it has something to do with this.
Yeah. So okay. So this is the dangling reference thing, right? So do you understand the error here?
Let me think. We are accessing R outside of the scope.
So yeah, so we create. I mean, R is outside of this curly brackets, right?
Yes.
And here we print it here. So this looks fine. But we here inside it, we give it like this R explicitly, not a new R. Like the value as the reference of X as a value. So this is then an error because, well, here we can't print the value anymore. And without it having a value, we can also not print it, I believe. Because Rust does not allow null values. So it does not live long enough. So, and here, so this is like the implicit lifetimes. So this has like one lifetime, right? So this value only lives up to this line, right? Yeah.
So we are trying to print the reference to an already dead variable.
Yeah. I mean, here we would actually like try to print 5. So if that would work. Yeah. So okay, yeah, here it comes again. Like this already is a problem. Okay. Okay. So this example is a little bit more closely to like our problem, like our code, right? So we need to understand why is this actually a problem.
Okay. So, but I would say this is homework for the next session.
Yeah. I mean, if you want to, sure. Yeah, but like look at this, right? If you want, we can also like continue with the code a little bit because like now it's clean up.
I actually need to go somewhere in a few minutes.
Okay.
So that's why I'll figure out the lifetime stuff until next session.
Yeah.
And we will also continue with the code next session.
Yeah. Okay.